Thank you, Adrian, and also Lucy for organising this. It has been somewhat of a dream to be able to speak in countries other than just the USA and very occasionally in Australia. So this is a great opportunity. 45 minutes to tell you how the universe works and give another example. The time starts now. I don't want to spend much time on this because I think it's pretty obvious to everyone here that physics is in crisis. But I put up this slide and particularly notice Dr. Sabine Hossenfelder because she's running a blog which is, I think, an excellent one. She's questioning everything they think they know. Her book there is How Beauty Leads Physics Astray. In other words, we've gone back into Pythagorean and Platonism, back into geometric simplicity, they call it. There was a lecture last year in the Perimeter Institute in Canada, which was talking about the simplicity of cosmology. And what do? They started with Pythagoras. It shows that the concentration is not on physics, it's on mathematics. The item down here saying going nowhere fast, after the success of the standard model, experiments have stopped answering to grand theories. Is particle physics in crisis? And this is by Ben Alanach, a professor from Cambridge. It is in crisis. You can see these books here are all written by experts. They're not just the public having a go at the experts. These are people who are expert in their fields. Alexander Unziker is involved in the Higgs experiments. Against the Tide by an astrophysicist, a critical review of by scientists of how physics and astronomy gets done, or not gets done these days. Peter Voigt, not even wrong. In fact, the questions are not even good questions. And Lee Smolin, The Trouble with Physics. Well, let's not dwell on that. But Sabine says, so many theoretical physicists believe in ideas that do not describe reality. They risk repeating the same mistakes. Theory development in particle physics for the last 40 years has worked mostly by the top-down approach, which has worked badly, to say the least. And top-down approach is you invent a new theory based on principles you cherish and then derive what you expect to see at particle colliders at huge expense. The bottom-up way is you begin with the theories you have confirmed already and add possible modifications. And this is the approach of the electric universe, because one of the most successful models we have is that of the structure of an atom, of orbiting charged particles about a positively charged nucleus. But there's a problem, you see, because of mathematics. A mathematical theory may be confirmed, that is, the answers come out right, without any real understanding of causes and effects. And in fact, modern science has done away largely with causes linked to effects. And Ben Alanach, who I mentioned a moment ago, says one of these questions is, where does gravity come from? We keep hearing that Albert Einstein's general theory of relativity has been confirmed yet again. Well, when you're working with a system that has no standards of measurement, rubbery lengths and rubbery time, clocks that are more like something out of Salvador Dali painting, of course you can choose your perspective to match what you want to get as an answer. Big Bang cosmology is a gravity theory, and yet we don't understand gravity. It depends on a force of gravity. But Isaac Newton said he couldn't explain gravity. And also, it's not mentioned all that often, but his bucket experiment, where you spin a bucket of water and the water rises up the walls of the bucket, he recognised meant that there's some connection between the water in the bucket and the rest of the universe. Otherwise, how would it know that it was spinning? And Einstein's theory of relativity doesn't deal with spinning objects. which, as it turns out, is a fairly crucial lack. Here's a video from BBC Two with a well-known commentator.
Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this: the reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the earth. So he concluded they weren't.
Fantastic. So Einstein did away with the force, and he did away with the rest of the universe. I mean, this is the kind of nonsense that we see on television, which is purported to be the most up-to-date science. It is logical, illogical, and it's nonsense. So he discarded the force and the rest of the universe, which wasn't bad going, since Newton had said that his bucket experiment showed there must be a connection with the rest of the universe. He ensured, by this stroke of genius, that mass, energy, and a whole lot of other things, light, all of these things could not be physically explained. In other words, he was no longer doing physics. So this quote attributed to him, I think, was quite accurate. In fact, towards the end of his life, I think he was rather disillusioned and felt that he, in a private letter to another scientist that was published much later, said that he had grave doubts that anything that he had done would last. I think he saw things a little more accurately than has been portrayed by those who have slavishly followed him. There's something critical here to understand, and that is that Newton's universal law, the form of it there is the mass multiplied between the two objects over the distance squared, it's an inverse square law, is identical to Coulomb's electric law. And nowhere in either of those equations do you see t or time registered. They are instantaneous, which suggests that the law, Newton's law, is an electrical force. In other words, they both conform to the physics of electrodynamics, which it turns out the continental scientists like Ampere, Gauss and Weber were dealing with in the middle of the 19th century and being very successful. So what happened was that Einstein forced electrodynamics to conform with electromagnetism or light and the cosmically glacial speed of light. This idea that it takes 4.5 light years for a signal to get to the nearest star and then another 4.5 years to receive an answer shows that it's a waste of time talking about the universe as a coherent system in terms of electromagnetism. The electric force operates throughout the universe and connects everything instantly. That's what that's saying. The problem, of course, with this approach using electromagnetism to dominate physics is we have isolation and disconnection. And because science is a cultural pursuit as much as a scientific one, this has a cultural effect too. It's a hopeless cosmology. It's more science fiction, and it has about all of the meaning for our lives as any other science fiction story. Maybe less. And of course, naturally, it doesn't work. Of course, one of the things that the pseudo-skeptics say, almost as a knee-jerk reaction to the very mention of the electric universe, is, show me the maths. Well, here's an equation that everyone has seen, but no one understands. Energy is undefined. All you'll read in the textbooks is that energy is conserved between electrical, heat, kinetic, and so on. Then the next thing is that mass is undefined. The philosophers are still wrestling with that one. How do you define mass? When you've disconnected all matter in the universe, the fact that something has mass remains a mystery. And also the speed of light in Einstein's system of thinking, where all observers are equivalent, doesn't matter how they're moving, means that the speed of light has no reference standard. Speed of light with respect to what? You can't measure your velocity in a car without respect to the road that you're running on. It has to be with respect to some standard. The standards have been removed, the force has been removed. It's no wonder that science sounds like science fiction these days. The simple answer is, of course, that, first I should say also that we still have this geocentric attitude towards science. So that when we establish a constant for the mass of an electron, the speed of light, the gravitational constant, they're all measured here on Earth, and then we just assume that they work throughout the universe. That's one hell of an assumption. So what does this maths relationship really mean? They're all properties of matter. So the universe is full of matter. That raises a question of what is that matter, but I'll talk about that a little later. I love this cartoon because it says everything in a very simple way, which is characteristic of good cartoons. And it also shows there that gravity is a balancing force because they've got this hovering spaceship. You won't believe the cosmology they've come up with. And I think in future, people will look back on the 20th and the beginning, I hope only the beginning of the 21st century. They'll say the same thing. People in future will look back at this era and say, you won't believe it, what they thought then. It's even flatter than the flat Earth. So I say to people who would like to learn about the electric universe that it can be a bit of a steep climb. So you have to engage a beginner's mind and pay attention to the person who's leading you and forget the mad world below, because the world is in a kind of madness, and even this aspect of our lives comes under scrutiny in the electric universe, and there is a possible explanation for it and a possible way out. And it's a way out that I think we have to take if we're going to have a future on this planet, because right now we're very destructive, both to our environment and to each other. The electric universe re-establishes principles. It applies the principles of classical physics, because in the 19th century we were far closer to the answers, and I've only just recently discovered that we practically had the electric universe in our hands in the middle of the 19th century. So we reapply those principles, and my job, as I have seen it, is to build this picture, which has meant roaming over all kinds of subjects. In fact, the science editor of the Canberra Times some years ago dubbed me the boundary writer of science, because I'd write in letters, and I'd have even the Nobel Prize winner Brian Schmidt responding to the things I'd said, but he'd publish both and publish my responses. And it was very funny because they had a Science in the Pub event one year, and I went along. I hadn't met this editor from the newspaper, but he was running the show, and he had a panel of scientists on a raised platform in the pub. And I raised my hand and asked a question, and he must have realised immediately who I was, and he introduced me to the audience. And he used that term, the boundary rider of science, and I thought, well, that's pretty apt. This is the other thing, of course, then, there are no disciplinary boundaries. And any cosmology must apply to any question that you can ask, because cosmology is supposed to be the umbrella under which all of science and all of our culture really operates. So if you want a real theory of everything, you can't just pick and choose one narrow specialty. The problem with modern science is that it's a cult of specialism. The other thing is, and this is the guiding principle for me, is to simplify. Nature is economical and not difficult to understand. And as I said, history shows the way. If we look back, you'll find generally that there's nothing new under the sun, that somebody else has already discovered it and been forgotten, or their contribution has been pushed to one side and history rewritten. Cosmology must illuminate all of our existence. And the result must be a coherent big picture. You don't just jam pieces in because you can force them in. They must fit and make sense of the ones around them. And this means that anyone can join in. And this is why I share where I'm up to, because this is a work in progress. It always has been. And I've made mistakes along the way and people have pointed them out, and I'm happy to accommodate them if they can give me a good argument. And this is why I would say, I've sometimes said that the electric universe is the home handyman's guide to the universe, because we have people in garages tinkering with experiments, and some of them are quite sophisticated and have produced excellent results. We don't need billions of dollars spent on Large Hadron Colliders and so-called gravitational wave telescopes. I have to talk about plasma, of course, because it is an electric universe, and we're told that 99.999% of the visible universe, and I emphasise visible, is in the plasma state. And plasma is the fundamental or so-called fourth state of matter. It should probably be the first state. It's before the positive, the positive charges and the negative charges organise themselves into atoms and so on. And unlike solids, liquids and gases, plasma is highly conductive, a better conductor than copper, and responds to electromagnetic fields. But it's not a superconductor, and yet astronomers treat it as if it is. They say it traps magnetic fields. The only way you can do that is in a superconductor. So there's a mistake right at the very beginning of plasma physics. Moving plasma, two different regions of plasma with different characteristics moving past one another, generate electric currents in each other. And those currents take the form of sheets, filaments and bubbles. The other thing then is that the motion of the charged particles in a magnetic field also produces radiation over large parts of the electromagnetic spectrum. So when people talk about the echo of the Big Bang, the cosmic microwave background, that word background is an assumption, because our whole galaxy is producing low energy down in that range of the spectrum. And the other thing is that it has been found that if it was background radiation, you would have a nearby large galaxy shadowing us. They haven't found that shadow effect, which suggests that it is the radiation from the electric currents within our own galaxy. Plasma cosmology is the physics of the real universe, because these people have gone right down to, talked about starting with simple models that have been well proven. And the atomic model of charged particles interacting is very well proven. And that's where plasma cosmology starts. But astrophysicists ignore it. I have here a quote from Hans Alfvén from Electricity in Space, first published in 1948. Whoops, that was odd. There was a recording there, and since... Oh, I see. Okay. Here we go.
There is one great branch of physics which up to now has told us little or nothing about astronomy. That branch is electricity. It is rather astonishing that this phenomenon, which has been so exhaustively studied on Earth, has been of so little help in the celestial sphere. Electricity has illuminated our cities, but has shed no light on stellar phenomena. It has linked the Earth with a dense net of communications, but has given no information about the universe around us.
Yeah, that's pretty telling. When you think of the uses we find for electricity, it's indispensable. To think that the universe makes no use of it is just a strange kind of blindness. The plasma cosmology is recognised by the largest professional organisation in the world, the IEEE, Institute for Electrical and Electronic Engineers. And they run special sessions. This, for instance, the big orange book here is a special issue on space and cosmic plasma. And I've had a couple of papers peer-reviewed and published in their transactions. Physics Today have published on the plasma universe. The book here by Anthony Peratt is a kind of Bible for those who want to learn about the detailed mathematics and so on of the plasma universe. And the book, The Big Bang Never Happened, is a very readable book, and it's available for a few dollars on Amazon, and second-hand you can, they practically throw them away. But that's quite a good description and explanation with simple diagrams of a lot of what I'm going to say in the next few minutes. This one is a quote from Anthony Peratt. Anthony Peratt was the author of the physics textbook of plasma. And he also worked with us for a few years and was very advantageous in showing us how all of the research that had been done over their lifetimes of several scholars, David Talbot, Eduardo Cardona, Ev Cochrane, they had pieced together what the ancients were trying to tell us they'd seen in the sky. And when Anthony Peratt came to our meeting in 2000, he shot to his feet and he said, "This is going to change my life." And he started sketching images on a whiteboard, which he had seen and were actually classified information, from the high-energy experiments at Los Alamos Labs, where they have electrical experiments feeding 100 times all of the energy of the power stations on Earth into something the size of a baked bean tin. They observe it from about 1 kilometre away through a telescope because they have to reconstruct part of the lab afterwards. But he was seeing the plasma behaving in ways which these people looking at prehistory and history, they had decided were what the ancients were trying to tell us. So it was the convergence of the latest in physics with all of this comparative mythology research. The results have been incredible. Getting back to here, so that's Tony Peratt. Georges Lemaitre on the left is the Catholic abbé who came up with the cosmic egg idea, which split open and everything was created. And Albert Einstein thought that was beautiful. And Hans Alfvén, on the other hand, had something to say about that.
To Alfvén, the Big Bang was a fable devised to explain creation. I was there when Abbé Georges Lemaitre first proposed this theory, he recalled. Lemaitre was both a member of the Catholic hierarchy and an accomplished scientist. He said in private that this theory was a way to reconcile science with Sir Thomas Aquinas' theological dictum of creation out of nothing.
He got it right, as in so many things, but was ignored. Here's another example. He had the integrity to, in his Nobel Prize acceptance speech, point out that some of the early work that he was recognised for was not applicable to plasma in space. And he did that in a very direct way. It wasn't sort of He wasn't pussyfooting around at all. And he warned that if they ignored him, there would be an inevitable crisis in astrophysics. Now, that speech was given in 1970. How long does it have to take? It seems things have to get pretty grim before those who have an investment in the current state of science will actually pay any attention.
We should learn that it is unrealistic to approach a low-density plasma by considering it as a fluid. Indeed, the plasma has taught me that it is so complicated that it should be regarded more as a living being than a dead mechanical system. Langmuir, who baptized it, understood this and borrowed its name from the blood plasma.
There's a clue there. There's as above, so below, a repeated pattern, and the fact that plasma organises itself, and as we're finding in the Sapphire experiment, in ways which we couldn't have actually predicted but we're happy to see, gives you an impression that this is a crucial part of understanding how the universe works, and that is the electrical behaviour of plasma when you feed electrical energy into it. Don't treat it as a fluid, like a wind, you know, the solar wind and a rain of charged particles. That's got nothing to do with it. You must look at the electric circuit. Any electrical engineer knows that. Unfortunately, electrical engineers are not astrophysicists. I think they should be. So how does electricity behave in plasma? Well, you've all seen these novelty plasma balls. And this little picture here, the Birkeland current filament, you've got two filaments here, and two parallel current streams, we know from Ampere's law, tend to pull together. But in the case of plasma, because of the differences in charged particle masses and so on, and you can see this in Eric Lerner's book where he describes all of this in more detail, as they come together, they twist around one another, and they form a twisted pair of filaments, which is something known to radio and electrical engineers to help prevent interference. In this case, you'll notice the ambient magnetic field runs in this direction. This Birkeland current always follows the local ambient magnetic field direction. Now, radio telescopes can map these magnetic fields of galaxies, and they were surprised to find how ordered they are, because according to standard theory, what goes on in galaxies is all bangs and you know, things colliding and gas blasting and causing shock waves. Nothing of the sort. The magnetic fields are ordered because the whole structure of a galaxy is an electromagnetic phenomenon. Forget gravity. Tony Peratt in his experiments compared them always with what's known as a particle-in-cell supercomputer model. And doing it that way, you're going back to electrodynamics. You're treating the charged particles as individual items and interacting via electrodynamic forces. And the result was that the experiments were mirrored by the computer models. Today, the computer models, if they don't get the right answer, they just twiddle knobs until they do. But the meaning of twiddling the knobs is lost. Filaments in space, we've already talked about that. Birkeland was an amazing pioneer because those Birkeland experiments showed all kinds of things, rings of Saturn, sunspot migration. He was a true pioneer of the electric universe. The other thing is that, of course, one of the reasons that the astronomers and astrophysicists have got away with what they've done is that you can't see these filaments. You need a radio telescope to pick up the magnetic signatures. They do become visible, though, where matter is concentrated. And that means that we can see these things and try and analyse what's going on. But the other thing is, of course, that it was a surprise to astronomers to find out that the structure of the universe is filamentary. It looks like a cosmic web that's been called. Well, the reason for that is that it's threaded by these Birkeland currents. And following the Birkeland currents allows you to trace the circuit. And that's what Alfvén said, that was crucial. Here's Alphane on the left, Tony Peratt in the middle, and Eric Lerner. This is from Eric Lerner's book, The Big Bang Never Happened. And this diagram here shows what happens on a cosmic scale. This is the birth of a spiral galaxy. Where you have pairs of filaments intersecting, they draw together and they continue to draw together, and as they do, they rotate around one another and they form spiral galaxy formation. Naturally, there's no magic involved. This is a natural form of the electric universe. Over here you see cross-sections taken at various points, matching the colours. You see this pattern forming, and the simulations in the supercomputers showed exactly the same form. So this is, I mean, this has been known for decades, but astrophysicists ignore it. And over here, of course, this is the looking down the barrel of an actual forming galaxy, where you see the core of the twin filaments lit up and the spiral tails of each one forming. So plasma cosmology shows both experimentally and by supercomputer simulation that galaxies and their 1 over the square root of r rotation, which my friend Don Scott will be talking about, are not governed by electromagnetic forces and not gravity. So applying gravity and saying, well, it doesn't work, we'll just sprinkle around some dark matter to make the equation work, is not the way to do physics. Okay. As for central black holes, the electrical model shows that the energy spirals in along the arms, and when it comes into the centre, it does what we find in what's known as a plasma focus.
For a few millionths of a second, an intense current flows from the outer to the inner electrode through the gas. Instabilities first compress the gas into dense filaments. These filaments are little whirlwinds of plasma.
Birkeland currents.
The sheath of filaments converges together into a dense pinch or focus, combining all the filaments into one. This filament kinks and twists itself into a tiny dense ball only a few thousandths of an inch across, called a plasmoid. Instability in a plasmoid creates powerful beams in opposite directions. Positively charged nuclei flow in one direction, and electrons flow in the other.
So this is the basic picture of what's going on in the centre of a galaxy. You'll notice they talk there of the plasmoid being only thousandths of an inch across. This gives you some idea of the storage capability, the energy storage capability of these tiny plasmoids. So in the centre of the galaxy, you've got a tremendous concentration of electromagnetic energy, and at some point it becomes unstable, and the particles down the centre of it start colliding and forming neutrons. And neutrons can escape the electromagnetic field, and they do so along the axis. And these devices in the laboratory are known as the most copious source of neutrons that they can produce in the laboratory. So galaxies do the same. The neutrons escape, they decay into protons and electrons, and then you have the raw material for forming baby galaxies. We'll talk about that shortly. And just recently, this is March the 13th this year, astronomers discover galaxies spin like clockwork. They found that all galaxies rotate once every billion years, no matter how big they are. Well, this is a total mystery, unless you realise that this is being driven like an electric motor, and all galaxies are driven by the same kind of motor. They all reach the same kind of speed, regardless of size. The other thing is that they found another mystery. Galaxies line up axially along intergalactic Birkeland currents. Why do galaxies align? I mean, if it's gravity just pulls stuff in randomly, and the spin will be, or the axis of the spin should be random. But these are spread over thousands of light years. And it's because they all will have the axis aligned along the magnetic field of the Birkeland current. So an electrical explanation, Alphane's circuit explanation, handles this easily. And the other thing then is that we can see that stars are born in and trace the spiral arm power lines. They're like street lights strung along the power lines. So electric galaxies, plasma cosmologists have calculated that the rotation of the galaxy in the ambient magnetic field is like an electric generator and will induce a current in the spiral arms of the order of 1 billion amperes. This gives Alfvén's circuit. You see the current flows out along the jet and comes in, completes the circuit. Now, the electric universe goes further than Alfvén did because he considered stars as the generator and galaxies as the generator. We see these as loads in an electric universe. So in other words, we're supplying power to them from outside. We've already said that. The plasmoid sits there storing it, and it exhibits strong gravity due to the relation between energy and mass. If you've got a very concentrated form of energy storage, it will exhibit, according to E equals mc squared, intense mass. But there's another aspect to it too, is that it's rotating. And a rotating object, when you understand electric gravity, will exhibit a very powerful attractive force which has to do with the polarization of gravity. So there's two things combined there. But black holes don't exist. They're a mathematical mistake, like dividing by zero, the schoolboy howler. And I recommend that if you want to know more, see Eric Lerner's book for a readable explanation. Now, Hans Alfvén actually predicted this is how stars would form. They form along current filaments in molecular clouds. It's like lightning within a cloud. And they form along the cloud like pearls on a cosmic string. This was a surprise too, because gravity doesn't tend to pull things together in a string. It pulls them together in clumps. Once again, gravity can be ignored. Ionized elements convect inwards from the molecular cloud along the filament towards the axis of the filament. And it's a long-range electromagnetic ion pump. It pulls in the charged atoms, the nuclei of atoms, in towards the central axis. And depending on where they pick up an electron and become neutral, that's where they stop. So it sorts the elements according to their ionization potential. The result is you get a cool core of heavy elements to form the center of the object, and on the outside you get hydrogen and helium. They're the ones that drop off the pump action first. Now this is important because stars don't have centers of hydrogen, so there's no thermonuclear activity. Said that. All stars have a cool planetary body as their core. There is no activity going on inside a star. The spin is imparted to the stars, and not only stars are formed, bodies of all different sizes, so planets are formed at the same time in the same fashion. None of this nonsense about a cloud of rubbish around a star, leftovers, forming planets. I mean, how do you do that? They've never been able to show how that works. It will remain a disk just like the rings of Saturn. This is a paper that was published which showed that the scientists have discovered how this happens. Here you have this filament, and remember the plasma ball we saw before with the filament snaking around? Well, this filament snakes around. It curves this way 1 minute, and over here it's straight, and then it begins curving the other way. This is the star forming, the core, protostar here. It's still moving with the filament here, but here it's picked up a certain amount of mass and the filament has started to change direction. It's coming back again. And in that case, the star is left behind, but it's got the original impetus of this filament. Tony Peratt explained it as like scattering like buckshot. This is what they observe. So you have stars and planets all being shot out fairly close together, so that when this is gone, as it moves away, the stars and planets are left to form gravitational planetary systems. And as Hans Alfvén said, gravitational systems are the ashes of former electrical systems. So this is why we can treat the solar system purely as a gravitational system and forget about electromagnetism when things are running like clockwork. It's a different thing if they're not. So there's evidence for planet birth. It's revealed a great abundance of faint brown dwarfs and isolated planetary mass objects in the Great Nebula of Orion. And this is the deepest view ever of this region and reveals more very faint planetary mass objects than expected, because they don't expect planets to form at the same time as the stars. We do. Here's a stellar circuit. This is where the Birkeland currents are actually lit up because there's sufficient mass and sufficient current density around this star to make it visible. And you'll notice they're concentric cylinders, but they're pinched down where the star is. I won't talk about the flyers. They're just a detail which the electric universe explains, but which astrophysics just doesn't understand. So the sun's environment, now I published this back in 2009, I think it was. Over here, this is one of these, pardon me, one of these inner cylinders, if you can imagine. We've got cut through here, and there's the sun, and that's the heliosphere. That's 100 times the radius of the Earth's orbit. Sun in the middle. So this is our little solar system here. This one of these cylinders comes down here, and it's a cylinder of filaments. The solar wind, as it's so called, it's actually part of the circuit. The charged particles come out here. They collide with the electrons in the galactic filament, and some of them get turned around, and they collect an electron and become neutral. And because they're now travelling back towards the Earth and the solar system, spacecraft in here are able to pick up these so-called energetic neutral atoms, they're called ENAs, and they have found something which was not expected. And it came after I'd put this diagram up on my website and also published a paper about it. Here's the answer, and here's Dr. James Ryder, who was a very good friend and unfortunately passed on unexpectedly a short time ago. He was the past Vice President of Lockheed Martin Space Systems Advanced Technology Centre in Palo Alto. When he retired, he had access to top NASA scientists, all sorts of people. But he came along to our meeting in 2012 and talked about the experiment that he was particularly involved in. That's the Interstellar Boundary Explorer experiment, NASA's IBEX experiment. And this is the one that was looking at these energetic neutral atoms coming back from beyond the solar system. And what did they find? They expected to have a cometary tail of the sun as it moved through the galaxy, you know, winds and collisions and fluids and stuff like that. What they found was, this is the galactic magnetic field, this is the way the sun's travelling, so if you're expecting a cometary shock front, it should be here and a tail back here. They found nothing of the sort. They found a ring of bright, almost twinkling, they changed over a few months, bright spots arranged around the solar system like that. That is where the sun's circuit meets the galactic circuit, and where they meet, they light up. So Jim presented, and he said there were 40 predictions before the IBEX mission went up. They all failed. In fact, the researchers gave up predicting. At one point, they said, we give up, we don't know. And then he showed verified none of the 40 predictions. And the hotspots changed in a few months, and this was way off the map. And then he put my slide up. This is the one. This is the picture, of course, that I showed you a minute ago. And I had these other ones here showing supernova 1987A with this ring of bright beads around it. This is an extreme example where the thing is lit up. So we've got one of those around our solar system too, and it's all part of this plasma Birkeland current system. So thank you, Jim. He said, summary of all Thornhill's comments. He said, this one shows promise. So the Sun-Galaxy connection, he says, this is what I wrote. The beautiful symmetrical patterns that arise in plasma discharges from very simple principles renders all modelling that ignores the electrical nature of matter and the universe worthless. And this is the picture I showed just a moment ago. I won't dwell on this. And this is the paper I published in the IEEE Transactions in August 2000 and... I can't read that. 7. Yeah. So it's 2007. I'd already put this up and drawn that diagram of how I think it works. And this has been a feature. It's been wonderful. It's easy to do. When you're on the right track, you see... What's the time? Time is up. Dear, oh dear. Okay. That, by the way, just quickly, that last one was a spectacular example of the circuit surrounding a star. It shows all of these filaments are the Birkeland filaments of the galactic current, and they come into the pinch here, and these are double layers, which will be talked about in the SAPPHIRE experiment and so on. These are very important, and they're where cosmic rays and that are accelerated, and they've actually been discovered near our solar system. So 45 minutes wasn't quite enough to get to the end of this, but tomorrow I'll be talking about where this is heading in the future, and that's probably of more interest than hearing what you've probably seen on YouTube videos over the last few years from me. That's where I really go out on a limb. So thank you very much. Thank you.